Okay, let's do the RGB LED. I found this one. I'm gonna start over. I just found out we probably have to modify it a little bit. Okay, so last time I did this LPF and microphone, so now we are focusing on the RGB stuff. So I just search for RGB, and there are several options. If you look at the one I found out from the bill of materials from Dr. Carlson's website, this is the LED we use for our PIC board, and here's the dimension of it. I'm putting here, yeah. So here's the dimension. You can see it's following zero. Here's a notch. It's following 1, 2, 3, 4 like this. It's 1, 2, 3, 4. So number 2 is a common anode. So I have to make it exactly the same in order to use this component for our circuit. So first, it has 4 pins. You can see it's okay if they don't perfectly match, since we can always modify it. So I'm just trying to use this one. Okay, let me make a snapshot just in case. Okay, I'm trying to use this one, right? And I'll just directly, no, I don't want to use it now because I have to modify it. So this one has a package of footprint of this. Okay, let's see if we can search for it. So if I'm making a library, okay, in my libraries, I don't think I have a LED library. So I just put in others, double click, and I'm going to create a footprint first. I'm going to import. I'll search for this guy, see if I can find it. Yes, I found it. And then click OK. So if you look at this one's dimension, here is about 2.2 millimeters. Okay, 2.2 millimeters. And 1, 2, 3, 4. Okay, 1, 2, 3, 4. So this need to be rotated. I'm going to rotate it. Oh, no. Select it first. And rotate. Put it in the middle. So it was 1, 2, 3, 4. So the order is a little bit different. So in that case, we have to rename it. Name. Let's put X here because this has to be 1, and this has to be 2, and this has to be 3, and this has to be 4. And I also want to create a little notch. Where is that? I think it's over here. A little notch here, so I can identify it on the board while I'm soldering it. So create a little notch. I think probably this little thing can represent the notch. Okay, let's just put it here for now. And look at the dimension. The dimension is 2.2 millimeters. And if I measure it, make sure you change the grade unit to millimeters, so it's measuring in millimeters. So this dimension has to be 2.2 millimeter. Press Alt on the keyboard so you can define a finer grade. Right? Click. Let's see. This is only 2 millimeters. It's definitely not enough. So I have to change the dimension a little bit. So I'm going to define a 2.2 millimeter first. I'll start from here, for example. Maybe start from here. Let's do a 1, 2.2, 1.1. Okay, 1.1 from here. 1.1 will be 0.1. Okay, let's do 1.14. Make it a little bigger, which is good. And so in that case, I'm going to pull these two paths down. I'm going to pull it down to here. All right, so these two shouldn't go down. Okay, I'm gonna put it up later. So 1.4 here, and I need, no, sorry, 1.14 here as well. Okay, so totally 2.28, so it's pretty close to that. Okay, pull it up, press Alt, don't have to press Alt. Okay, so now pull this back, press Alt. All right, and keep this here to indicate the notch. 1, 2, 3, 4. And if you look at the dimension of the pads, the width of the pads is about 0.7. Let's see if this is big enough. 0.7 millimeters. 0.7 millimeters. I have 0.75, so it's perfect. So this is perfect. All right, I'm gonna delete this as well. We're not deleting the value here. So pull this back. Delete this guy. Better here. Put name here. Okay. So 1, 2, 3, 4. And the dimension here is correct. Now let's check the horizontal dimension really quick. It's about 3.5. 3.5. So let's check. 3.5. Right? It's very close, very close. So I think this is fine. But we may prefer to make this a little bit longer. So I'm going to stretch this out a little bit so it's easier to solder. So I'll select it and just do this. That will be good enough based on my experience. Sorry. Nope, it's selecting the grade here. Let's just do this first. Okay, just a little bit, right? And then pull this back. And now let's measure it. Press Alt, okay? 3.68. 3.8. So if you look at this one, it's about 3.5. You know, I actually prefer this to be to go out a little bit more, because just for soldering purposes, right? Just for soldering purposes. So now I'm gonna do this. Okay, and then measure again. Okay. Yeah, this looks a lot better now. And we can move everything towards the middle by doing this. Okay, so it's not snapping to the grid because it was a grid we selected was a bit too big, but I think that's fine because the dimension wise, this is gonna work. I'm gonna save it, and now we need a symbol, right? It's the symbol. So we wanna import that symbol. So we just do it over here and search for, symbol import, and search for that RGB stuff, RGB. So you can find that one. I think this is the one we want, okay? This really doesn't matter. And if you look at the dimension, it's 1, 2, 3, 4. 1, 2, 3, 4. So we want here to be 1, 1, 2, 2 here, and 3, 4. Okay, that's the order of it. see. Properties 1. This is 1. Yes. Name, it's 1. Okay. Name 2. Name 3. Name 4. So it's 1, 2, 3, 4. 1, 2, 3, 4. And if you look at here, it's going to be 1, 2, common anode, 3, 4. This is RBG. Okay, that doesn't matter for the colors. So if you go to footprint, now let's create a device. I'm going to call it my RGB. Create it. And I'll just directly find out that this guy, just create it, right? Put it in the middle. And do the local package. And the one I just created, which is this guy. Okay. Import it. So you don't have to worry about the connections because we designed the 1 to 1, 2 to 2, 3 to 3, 4 to 4, so just directly connect. And that's going to work. And save. Okay, so now you have the RGB LED now. Oh, this one has some shape over here. It's not getting addressed. Interesting. So let's go back to the footprint and edit that a little bit. So I'm going to come here, go to others. Let's close it first. Go to others and find out that footprint is over here actually. So it doesn't show that color because I didn't show all the layers, and now it shows up. I'm wondering what's a tea cream. We don't need it. I don't know what that is. I don't think we need it. We don't need that layer. Okay. And make sure this is on the T dock. Let's put it on the T place as well. I don't want to mess with it. I'll just copy and paste and put it on the top. Okay. I grab it and select the 21 layer. Okay, for that guy. And put it back. Save. Okay, so now this guy is ready. If we go to our device, I think we'll just pick up my. Let's close this one. Close this one. And go to schematic and just add our, like the other way that I showed you. So if you do this and go to my RGB, okay, double click, you can add it. This is the easier way, so you don't have to keep searching for that. So this is my RGB 1, 2, 3, 4. You can see it's aligned with whatever being shown here, 1, 2, 3, 4. It's going to show a little indicator to let you put a notch so you know the orientation. And let's measure it. So this is 3.5 and this is 2.8. Let's see if this is right. 3.5 and 2.8, okay? 3.5. See, we definitely have more than 3.5, so we have more space for soldering. And 2.8. 2.8 is very close. See, it's very close. It doesn't matter because the metal can definitely. Because I didn't put at the very beginning here. So let's probe here. Probe here, okay? 2.8. See if that's accurate. See what I'm getting. 2.54. So what I have over here. 2.8 is over here, but here is 2.2. Okay, so this is perfect. All right. So both dimensions are perfect, and I think it's ready to use. It's ready to use. Now let's add resistors to it. And you can see for RG and B, the resistor values are 139 and 910. So I think we can. It's really interesting because remember on the board the colors are actually incorrect. It's not matching the label. Remember on our PIC board. So what I'm thinking is this accurate? I don't know actually. So, but usually for protection purposes, 200 ohm resistor will be adequate. So it's okay because we are using the same footprint. If it doesn't work, we can always swap it and using a different values, right? So this part is actually pretty simple. We'll just keep adding to it. You can directly copy and paste the resistors. Just anyone, doesn't matter, since we can always change the value. It's the same footprint, okay? It's the same footprint. Do this and make the connections. Remember, there's a header pin on it. I think it's really important because eventually we are putting jumping cables to it as in the testing phase, right? So I think let's use connectors. So do connector. I think the SparkFun library has really good connectors I've been using for a long time. But any connectors work, okay? Doesn't really matter. So for this existing tutorial, we used header pins. It's a different name. If you want to keep it consistent, we can just use the same thing. So this is from the, it's called header pins, I think. It's pin header something, pin header. So if we search for let's see if that works. These ones, right? So it's 1x2. That's been selected, footprint required. Okay. So grab 1x2 like this. And 1x3, sorry about that. 1x3 like this. Rotate and select the entire area. If you want to rotate it, that would be really nice. So it's 1, 2, 3, 4. Let's identify which one is which color in the footprint. Okay, it's over here. So that is, one is red, right? So one is red. So I'm going to label this terminal here as red. So we're not making that same mistake. So this one, let's call it red. And number 2 over here, number 2 is the VCC. And number 3 is blue. Number 3 is blue. Here's 1, 2, 3. Here's blue, right? Here's blue. Okay. And this must be green though. Okay. And it's RGB. I think this is perfect. And then we just because it's really just next to it, I'll just directly make connections. Okay, and save. So this RGB part, I think, is done. Okay, we really don't need any other things because eventually you can use a jumping header to connect the GPIO pins to these ports and control the IODs. So if you come back here, you can do the same very similar layout as what Dr. Carlson did. But since you have jumper pins, usually you want to keep them at the edge of the board, but that really doesn't matter. You have so much space over here, you can place it anywhere you want. Okay, so but follow that layout. See if you look at the layout here, right? You got LED. So So this part, right? So pink headers on the top. Okay, and 3 LEDs. Right, 1. Let's see, R, and this one has, see, zoom in, it's RGB, that order. Okay, let's rotate it. So we're getting RGB. Okay, and R, G. We'll take it one more time. And B. Okay. RGB. All right. And LED here. LED here. So it's not tangled. So it's following a certain order, so it's not getting tangled. And this one, just directly place it here next to it. So that's perfect. Right, so we're done with the RGB module here.